to understand the importance of data. And then we'll do some exercises to identify patterns, and we're going to put together a data set. So that's where I need everyone to be very interactive and contribute. I'm going to teach you how to identify noise in the data and show you how to deal with missing data. And then with the data sets that we're going to put together, we'll also identify patterns in the data set. And lastly, we're going to create a model. Now, the model is, we're going to create it with our own mind, our logic, and we're going to talk about how to apply that model in real life. Now, the example I'm going to give you is something you all will be able to relate with. It's something very simple, and it's a real life scenario. And so lastly, this came in based on some questions I saw that people already asked. We'll talk about data roles and career path. And I see some people already asking, what can I do to become a data scientist? All right. So before I move on to the next slide, I want to say again, please stop painting on the screen. I really appreciate that. So everyone can see what's on the screen. All right. So the next slide is going to be about me. All right, so this is Moyo on the left, and I do many cool things with data. I do a lot of predictive analytics, and I help companies, businesses, I help them build their data pipelines as well. I help schools, clinics, government, big and small businesses operate better, right? And that's with the use of data. And the interesting thing is I didn't start all of these until I was 17. So a lot of you are probably younger than that. So that's a very good thing. That gives you an edge. You're able to function and understand how computers work. And if you don't know how to use a computer so well, this is also a way to encourage you not to be discouraged, right? And push you to go for what you like to do. If you go to the website there, that's my little space where I talk about myself. Before I even decided to do computer information systems, I had no clue what computer science was. So I see some people already talking about being developers. So don't worry about where you are right now, okay? What you want to seek for today is understand what I'm saying, and that's why I've made it very simple, okay? So I did my BSc in computer science with a focus on information systems, actually called computer information systems. And then I did my master's in data science and business analytics. And what you see below is my website. All right, so we're going to begin by watching a video. I will share this. If you don't hear the sound, please let me know. Let Olumide, please let me know.
Sure, we will. I will.
So all right, so what you saw in the video may seem far-fetched. Can I adjust my headset? All right. So not so many cities are like that. That was a smart city. And you don't have to feel we don't have anything like this around. That was to encourage you and to let you see how data is used. So data is something very significant in everything we do. It helps us live better. There are ways that we can put data together that will benefit everybody. And that's why data is not meant for just a particular industry, a particular set of people. Data is for everybody, all right? So think about anywhere you can think of, data is everywhere. So when you think about the government, that's exactly how the smart city works, right? That's something the government or even private companies can put together. You think about bills, when you pay your electricity bills, that's data. When you go to the hospital, they bring out your file, they talk about what happened before and what's happening to you now, and your doctor is writing everything you're saying. That's data. Think about your schools, when you get your report cards, when your teacher teaches you, when you log into an application, when you register for a program, all of that is data. And of course, YouTube videos, because I'm very sure you all like YouTube. YouTube video, even though it's video, it's data. When you go to the stores, regardless of how small the store might be, they keep track of the stock when they need to go back and replenish what's missing. That's data. And for bigger stores that already know the customers are coming, or maybe places like Jumia, Konga, and the rest of them, all of that is data. Think about your phones. When you call your friends, you have their contact details. You store it somewhere. That's data. And for those of you that like sports, you watch the Olympics, you watch FIFA, all of that is data. And let's pull this to the side. All right, video games. I'm sure you guys like video games. Video games, everything is also data. When you try to, you're playing a game, you log out, you log in again, and it tells you where you're starting from. It's keeping track of what you're doing, right? All of that is data. And guess what? I don't know what games you guys play, but during my time when I was much younger, I used to play Mario, and my son is teaching me how to play Minecraft right now. And I'm struggling with that. So once again, please stop writing on the screen. All right, let's stop that. Thank you. So data is everywhere. Data is used in everything we do. What might be different is the way we store it, is the way we collect it. It's probably done this way through paper. Maybe you have to fill a form, or for you to get something, it has to be printed out for you. And in some other places, especially banks, for example, when you want to withdraw your money, for those of you that have ATM cards, you have access to, you have a card, you go in there, you slide it in, you get your money. Some people still have to go into the banking hall and then fill a form. When you go to the hospital, it's possible your doctor is still writing on a sheet of paper as you talk or as he's asking you questions. Regardless of how the process is done, okay? It's still all about data. And I need you all to understand that whether you're a data scientist or not, you're going to be working with data. And I want you to begin to see the best way to store data that will make you more efficient and that will help you to be more productive, all right? So we're going to move on to the next slide. And the next slide, we'll start our exercises. And this is when I'm going to start asking you some questions, all right? So what we're doing today is we're going to predict whether it's a teacher that you know in school will be an excellent home tutor for you, right? We all have teachers, so we cannot relate to that. Now, is this teacher going to be a good lesson teacher for me or not? Let's see how we're going to do that. We begin with this exercise, all right? How will you arrange these items into two groups? Now I'm going to need answers. How will you arrange these items into two groups? What is going to be your pattern? And can someone tell me that? Shapes. Yeah. So what are the circles and quadrilateral? I like that. Awesome. So that's the answer, right? Okay. You guys are awesome. That was pretty simple, right? Yeah. And that's exactly how the machine works. Okay. It seems very simple and you're like, really? Oh yeah, really. I'll tell you where the difference comes. But this fundamental understanding is really how the machine also works. It's you've identified all the shapes and then you've seen that some are four-sided quadrilaterals and round shapes, regardless of whether it has a hole or there's a cross in the middle or whether it's all solid, it's still the same. All right. Now, the next exercise I have for you, you're going to tell me what comes next, and then you tell me what the pattern is. There are three of them, so don't just say, I need the three answers. Dami 101. All right, so I've seen several answers, and so the correct answer, and you guys are thinking right, trust me, you're on track. I already have data scientists here. Omolara. All right, so I'll take this down, and this is the answer. It's 34, 36, 37. And the pattern is you add 2 and 2 and 1. All right, so it's +2, and then +1. Okay, so these two patterns, these two exercises that we've done, one is what you can consider classification, right? They're classifying the objects that you've seen. These objects are similar in some sort of way, okay? And so they will belong to the same group. Now, this other one is continuous. Continuous in terms of it's a number, it's measurable, right? You're able to see this is adding 2, and then 2, and then 1. So when you're doing things like, I want to predict how much money I'm going to make when I sell my shoes. You probably sell shoes, for example, and you want to say, I'm going to predict how much I'm going to make next year, next month. Now, that is a continuous thing because you're measuring a value, right? Now, when you want to say who is going to be my friend and who is not going to be my friend, now that's classification because you're grouping people into groups, right? Into different groups. All right, so those two things are very important to learn. And so I have to keep moving something to see my screen. All right, so patterns, it's the foundation of machine learning. It's trying to see what's making the change. It's trying to see what's making one to be in a particular group or how similar objects are. So we study the patterns to classify similar things together or know how much they will they will change and when. So that should be they will change and when. Okay. So for every 2 years, I'm getting a particular value, or my value is going to increase by 2 the next time, and then the next time is going to increase by 2, and then the next time is going to increase by 1, and the next time it starts again at 2. That's another pattern. Okay. Always understand that as simple as that is, you can apply it to your data. All right. And so before I begin to say that, let's talk about data. So I have a picture for you here. Take a look at this picture. She's a woman. And you want to gather some information. So now we're going to chat again. Can you tell me some kind of information you like to know about her? Right? If you don't like her being a woman, you can think of a man as a teacher. So this is your teacher. And you want to gather some information. What kind of information or what kind of questions are you going to be asking to know about her? The name? Yes. Age? Good. Where she's from? Nice. Occupation? I like that. Nationality? Wow. Physical condition? Nice. Subject she's teaching? I like that. Okay. Her profession? Okay. Marital status? Good. Experience? Nice. Blood type? Anger management? Data plan? Oh dear. Hobbies? Nice. Good. If she has children? Awesome. Religion? Good. Complexion? Good. Schedule? Behavior? Phone number? Religion? Okay. Interest and aspirations. Temperament? Good. Job experience? Is she married? Phone number? Future ambition? Likes and dislikes? Friends? CV? Awesome. So I'm going to pause this. Uh-oh. Okay. I like the answers you guys are giving, because for me to do this, I called my son and we set this up together because, of course, I had to prepare something ahead of time. And this was what he said. Age, subject, kids. He also talked about kids because he likes to play. He wants someone to play with. And is she nice? I'd like to know her name. I'd like to know her address. And does she like games? She just likes games. And of course, he likes watching TV. So does she enjoy watching TV? Because for her to teach me, we're going to talk about the things I watch. And she should be able to follow along. Is she fun to be with? What food does she like? Right? So we put all of this together, and this is data, right? I'm just making it very simple because it really is simple. This is data. But I'm going to show you how to represent this data in the computer, how you're going to put the data together to form a data set, what you call a data set. And that's what the next slide is. So you have your headings, which would then be the kind of information you're looking for, and then, of course, the answers. So you have a Mrs. A, who is 25 years old and lives on Street 19. She has 2 kids, and she is nice, right? Nice means it's a question. Is she nice? Yes. Does she like YouTube? Because, I mean, considering the way I learn now, I would like a teacher that will refer me to YouTube. And is she fun to be with? If she's a boring teacher, oh my God, I don't think I would want her in my house. And of course, she has to be very good. What's her rating like? So teacher rating as well. So this is a data set. And this is something you're going to be working on as your assignment. This is how to put together a data set, okay? And the second record is also there. I'm going to pause here and ask for questions. Any question on what we've talked about so far? If you want to speak, you can raise your hand, and the coordinator is going to unmute you.
Koshife, please proceed. You can proceed to speak now. So if you want to ask a question, please raise your hands and we'll unmute you.
Um, so I wanted to ask a question. Please, the data or the data set. So does it necessarily have to be like in a table? Like, can you just type the information normally in lines?
Are you done? Okay, I thought you were still asking. Okay, so how is data represented? It's usually, right now, to keep it very simple, it can be text, it can be a video, right? Remember we talked about different kinds of data. So it doesn't have to be in a table, because a video will not fit into tables the way I put it for you, right? And that's more like advanced kind of data management, where you're going to extract information from videos or extract information from text. Text, like, the way you send text messages to your friends, chats, and all those messages on YouTube, on Facebook, LinkedIn. Yeah, all of those are called text kind of data, unstructured data. So when the data is structured, I did not put that in my presentation, but your question is are you're comparing a structured form with an unstructured form. Structured form is the one that comes in a table like what I have for you, or structured will be text and the likes of them. But with unstructured data, it's for you to be able to analyze it very well, you have to be able to extract the data in such a way that it becomes structured. Okay? It becomes structured in some form of analysis that you want to do. And in some other forms, it could just remain as it is and you're extracting the information you need from it. Does that help you? Gusife? Is that how to pronounce your name? Yeah. One more person, please.
Yes.
Oyedutola, please proceed.
So I wanted to ask that when did data start?
That's a good question. When did data start? Or maybe we should say, when did we start collecting data, right? Or when did we start recording data? Data started right from the world, from when the world started, let's put it that way. Because remember, data is information, right? So information is when the world got created. Information is when a child was born. Information is when a name was given to a child. So I would say data existed right from the time the world existed. Okay, but maybe what we should say is, why is data now such a big deal, right? Why is data now such a big deal? Yeah, it's because of the value we're seeing in it. Okay, the value we're seeing in it, because people now understand that if I can get this information and I know this and I'm able to do this kind of analysis on it, I'm able to make this kind of impact. And so it's now a big deal, because before nobody was looking at it, nobody thought it was necessary. Everybody just felt, yeah, it's okay to gather that information. And depending on what you're doing, I would say maybe only in the banking sector that, data is very, very crucial, because that's the only way you're going to withdraw money, right? Everywhere else, it's a nice to have. But now everybody is thinking we really need to start making use of that data. Well, good question. So Olamide asked, when data is extracted, can it be summarized? Yeah, it definitely can be summarized. And that's not what we're doing here, but yes, that's a very quick answer to, can Nigeria ever become a smart city? I like that question. And that's the question I'm going to ask you. Because by the time you guys are, in the university, you're out, By that time, we should be talking smart city. So do you want to play a role in making Nigeria a smart country, in having smart cities? And you don't have to think of Nigeria as a big, that one entity. Think about Lagos. Think about Agege. I see some of you living in Agege. Think about Ikoyi. Think about Egbeda. Think about Ikeja. Just think about where you live. How can I begin to make this city or this community a smart community? Don't let's use smart city. How can I begin to make my village a smart village? All right. That's how I need you to start thinking. So I like that question. All right. One more question to be asked.
Awesome.
Okay, Arauluwaki, so please ask your question.
How can you protect data?
Awesome. So data protection there's some tools or some programs that are in place to ensure that data is protected. And there are various ways to look at it. You can look at it from the software angle, programs, right? Or you could also look at it from a physical entity, like a building, or you could also look at it as the people accessing that data. So there are some certifications that certain entities, like the government, like the banks, like any company whatsoever, will have to take to ensure that they've put measures in place to guard against data loss or data getting into the hands of the wrong people. And the standards are, if you read ISO standards, you see information security. So guarding data is not just looking at one thing. It's a responsibility. It's just like the responsibility of you going to school, right? Someone has to take you to school, or you take the bus, and someone has to teach you. So there's so many parts into data security. And I'm thinking of a very quick way to say this without saying so much. The softwares, the people have to be people that have access to the data and not to misuse the data, right? And that's why in some hiring processes, they'll tell you to do some kind of test to be sure that you're not going to steal data in any way. So data is protected with softwares, getting people, and processes. All right. So please stop drawing on the screen. I'll really appreciate this. All right. Thank you. So we'll move on to the next section. All right. Now, when you have a data set, there are two things that you want to be mindful of. You want to be aware of. You have your independent variables and you have your dependent variable. Now, how can I take this out of the screen now? This drawing. Independent variables. Can we please stop drawing on the screen so everyone can see? Independent variables are the variables that will predict, right? The variables that you need to determine what you're looking for. What are you looking for? That's your target. You want to know if this teacher is going to be a good tutor. And that's the last one I have here. Is this teacher going to be a good tutor? And then what are the things that I need to ask, or what are the things that I need to consider to determine that? So those are your independent variables. And you can call them your predictors. Okay? Now, we're going to talk about missing data. All right? And there's an exercise here, and this is very simple. I probably should even bother asking. So when we have data that is missing, which is down here where my mouse is, Mrs. P does not have a teacher rating. For some reason, teacher rating, I think someone did ask about teacher rating. It's just like teacher ranks or teacher score, whatever you want to call it. But in terms of how do students rank this teacher? Do they say she's good, or do they say you don't want to go there, right? So that's what teacher rating is. So for Mrs. P's rating is missing for some reason. We don't know why, right? But then how do we go about rating her? Because it's important. I need to know if she's really good. So there are many ways to handle missing data. The best way to handle missing data is really to get that data. Go look for that data. But then there are times that you really can't. Now, when you cannot, there are other things you can do, and that's you can use mean or median. Right? And these things are still in use today in very big companies. All right. So you have your teacher rating. Can somebody tell me what the mean is? And can somebody else tell me what the median is? I think median is pretty very simple. Yeah, so can you tell median is 7, correct? Jafar, Ajibola. Yeah, mean is average. So what's the mean? What's the mean? Mean is approximately 8. Okay. All right, so that's one way to handle missing data. There's so many other ways, and because of the kind of questions you've all been asking me, I will give you more information on other ways to handle missing data. Missing data, depending on the number of missing data you have. Imagine now that we have how many records here? We have 7 records here. Now imagine that out of those 7, 6 are missing teacher rating, and you just can't get it, right? 6 out of 7, can you calculate a mean, right? If that means everybody's gonna have a 7, right? And you know, for some reason you have an idea that, well, I think Mrs. G, she's pretty awesome. She can't be a 7, right? She can't be a 7, she's a 9. And you know, that's the true value. So sometimes when you cannot get enough information about a certain variable, so I'm going to start using the terms for you now, all right? When you don't have enough information about a certain variable, then you just have to let it go. Because if you don't, then you're just guessing. And when you guess, you're making decisions on what you guessed, you know, about. And that's very dangerous, because imagine you have 2,000 records, and out of those 2,000 records of this same data set, you only have 10 teacher ratings. Now, because of those 10, the influence of those 10 will then affect every other person. So if those 10 are not so good, everybody's going to be assumed as, every other teacher is going to be assumed as not so good, right? So when you have situations like that, you have to struggle very hard to get the data if it's very important, or you just take it out. Another way to go about it is to impute the data. That's another form of guessing, but in a better way, kind of. Now, imputation is done also in different ways. Imputation can also be done using machine learning. The same way you're studying the patterns and seeing the variables, it's also another way to systematically guess what's missing. Okay, I don't have any of those here, but I just thought I could share them with you. All right, so now we're going to talk about noise in the data. And so what is noise? I'm sure you've all read this by now. Noise is meaningless data. You can't understand it, or you can understand it. It's good data, right? But it's not something that's going to help you in any way. For example, the name. The name of your teacher does not affect whether she's going to be a good tutor or not, right? Let's, except if you want to put sentiments in it. It doesn't affect address, for example. Let's assume coming from a far distance is not a problem. We're not looking at distance, but where she lives, let me put it that way. If she lives in a small house, or a big house, in a yellow house or a red house, it's not relevant to whether she's going to be a good teacher or not. So because our data set is small, and because we kind of know what we're looking for, that's us acting as the machine now, right? We can tell right from the get-go what's going to be considered noise in our data. So our noise here will be name. Our noise here can also be age, because it doesn't matter whether she's old, young, as long as she's a teacher in school, that's all I want to know, right? It doesn't matter where she lives. So those three columns can be considered noise. Now, noise in the data, when you're dealing with a lot of records, which is where machine learning really comes to play. A lot of records can be 500, can be 1,000, because you can't be looking at 500 records to begin to make decisions, right? It doesn't have to be what we call big data, like millions and billions of records. It doesn't have to be like that. Now, when you have a lot of records, it's not advisable that you do what we're doing, right? What we're doing today is understanding the fundamentals. So don't just take it as, oh, when I have 600 records, or maybe looking at the number of students in my school, we can begin to sit down and begin to guess things. You might begin to come up with good ideas, but at the end of the day, it's going to be tiring, it's going to take a long time, and it's subject to errors. All right. So we take out all of the noise in that data. Now I left name just so that we can see, we can tell who is who here. The records, we can identify the records here. So we see Mrs. A, she's a good tutor. We see Mrs. D, she's not a good tutor. We see Mr. C, who is, and Mr. B, who is not, and on it goes. Now, this is where I'm going to give you some work. Looking at this data, can you tell me what makes a good tutor? Based on the same exercise we've done, now we're applying that same logic of identifying patterns in a data set. So can you do that now? And I'm going to my chat. Please stop writing on the screen. You should be writing on a sheet of paper. I can't see my chat. So Olunde, can you please help me? I can't see chat, so I don't know who is responding. I don't know if anyone would like to speak. Would anybody like to speak?
Okay, so there are a few comments or answers to your question. Someone has indicated according to the teacher's grade, teaching style and behavior, nice and grade, and if the teacher's grade is above 6. Could you please stop writing on the screen so that we can enjoy this session, everyone? Please stop writing on the screen.
Okay, would anybody like to speak?
Bash, could you please proceed?
Hmm?
Mommy, see, he's spoiling it for everyone.
Yeah.
So that
Olumide,
what kind of nonsense is this that this boy is doing?
Have you answered about the teacher? Is that more?
Oluwatimileyin, could you please answer, ask your question?
I believe that there is no correlation between some of the data in the data sets, because the last two teachers had the exact same data, yet one of them was seen to be a good tutor while the other one was not. And they both have everything else. And well, I really can't see why some will be a good tutor or not, apart from the ones that obviously aren't fun to be with or don't like YouTube. But apart from that, I don't think dataset gives the most. I don't think dataset tells us everything so far. Thank you.
Okay, so I was muted before. So I said, I like your response. I will get an answer. I'd like someone else to speak, please.
We'll take a question from Oluchi. Oluchi, please ask your question.
Is there a question now? She wants to answer.
From the data sets, I think
Okay.
if we can make a graph from it, then we could be able to analyze it and maybe find out which is a good tutor or not. Because if I say I'm choosing from the teacher grade, I can't say that someone from above 5 or 6 would be a good tutor because Miss G is 9 and she's not a good tutor. So my suggestion is to make a graph and analyze it. Thank you.
Thank you. Toby, could you please provide your answer? Your mic is.
So I think that we're looking at the patterns in the data set right now. And some people say that the person is not a good tutor and a teacher grade is higher, a teacher grade is 8. And people who think that teachers are a good tutor, for example, Mrs. A is a good tutor and she got 7, which I think is not very analytical in this data set because we're looking at patterns right now. So I think that the students in this school who think about their teachers as nice or not, they should give the good teachers a higher rating than the bad teachers. So thank you.
That's awesome. All right, so because of time, I will wrap this up. I like Oluchi, the three of you. I'm so proud of all of you, and I'm sorry I'm not reading the chat. So I'm very happy with all the responses I've seen so far, and I can see data scientists already in the making. Mrs. G, for some reason, I don't know what happened there. So I like the way Oluchi pointed that out. Mrs. G should be a good tutor. But to give the answer this is what makes a good, this is an equation to determine a good teacher. she has to be nice, and you see Mrs. D. Mrs. D isn't nice. Let me clear my screen, and I hope whoever is doing this will not do this again. I will really appreciate that. Okay. So please stop writing. I'm going to clear my screen now. All right. So, yeah. So if you look at Mrs. D, Mrs. D has a good score. She's an 8, yet she's not a good tutor. And you see, she's not nice and she's not fun to be with, right? But then you look at Mr. C, he's a good tutor and he doesn't like YouTube. So YouTube, not liking YouTube is not a problem. So if he doesn't like YouTube, yeah, no problem. But then he has to be nice, right? And he has to be fun to be with. Okay, so if you look at Mrs. D and Mr. C, those two will tell you also that, well, number of kids is not necessarily relevant, even though my son said he would want a teacher that can play with the kids as well. But when you're coming to my house, you're not likely to come with the kids. That's, how your parents probably look at it. So number of kids is not relevant. Liking YouTube is not compulsory, right? What is compulsory for you to be a good tutor will be that you have to be nice, you have to be fun to be with, and your teacher grade has to be more than 5. Because if you look at the person that scored a 5, Mrs. E, Mrs. E is nice, she's fun to be with, but she scored a 5. And so she's a no. And so it's because her teacher grade is low. That's relatively. That's why she can be a good tutor. Any question on that? On the way I've explained is, let's take out Mrs. G. I'm not sure what happened there. So it's probably when I copied and pasted and I didn't make some corrections. All right. So any question on what I've asked, on what I've explained so far? I like Mrs. F.
Okay, can we take a question from Ukeme and Idara? And then Grace would go next.
Oh, the question I wanted to ask is the same thing people wanted to ask, so don't worry about the question anymore.
Okay, awesome, thank you. Grace, your question, please.
My question has been answered.
Awesome. Ibrahim, your question, please.
Okay. My question is that why is it impossible for data to be unhackable? Like, why is it that data can always be hackable? You can always hack data.
So that question is similar to why is it that thieves always steal, right? Like, why is it that we always have some form of robbery, or we're always guarding against attacks? And yeah, that's because some people just do that, right? And the same way you have some engineers or some developers dedicated to doing or building solutions, is the same way you have some dedicated to messing it up, or looking for a way to steal it, or looking for a way to just have access to it. And now that it's no longer a thing of with stealing money, or some are now beginning to steal data. That's how important and the significance of data. So data security will always be a problem, right? For as long as people choose to steal.
Okay, thank you, Moyo. One more question from Oyeduton Oyetola. Please take your question. Please, if your question is not answered, if your questions aren't answered in this session, we are noting all the questions, okay? And then we'll share the answers to those questions on our website. Okay, so you can go to our website to access it the answers to those questions after our session. Oyeduto, please ask your question.
So my question is that if data is displayed, is it always equal?
Data is, I'm sorry, I didn't get you there.
If data is in the same place, is it always equal?
If data is in the template, is it always equal? Olumide, I'm not sure if you heard her because I kind of lost time while she was asking the question.
I also didn't clearly get that.
Yeah.
So maybe we'll take our final question. Molumo Yusuf, could you please ask your question?
My question is that the data that we're dealing with here that is in table is simple and we're finding it easy to relate with. What happens if the data set is not large and it's complex? So how do you deal with that kind of data?
Awesome. So I like that question because then it brings us here, which is we've just created a model. All right. And I would want someone to tell me what a model is. But then to answer your question, like I said earlier, what we're working on is understanding how the machine itself is going to operate. Now, when you talk machine learning, right? That's the machine doing the learning by itself. You are doing the learning as a human being. And as a human being, you can only work with just as little as a couple of records, right? But as a machine, then you're dealing with like 1,000. And so that's where the coding comes in. The coding comes in, and then some algorithms, and that's where statistics also comes in, will now be applied, right? So what you have just done, looking at the records, applying the patterns, understanding how it works, that's exactly what the machine is also going to be doing. The difference is the machine will be able to do faster and will be able to handle a lot more, okay? So I don't know if that answered your question, but our focus today is to introduce you to the role of data and to teach you how the machine works so that even if you have a few records, you can also work with it and begin to make models yourself.
Okay, awesome. Thank you, Moyo. We're beginning to wind down the session now. So as I said earlier, if you still have questions that are unanswered, please still feel free to drop them in the chat section. We'll filter and provide responses to them on the TechQuest website. So you can look out for that after this session. Moyo, I would like to ask, how do the participants of today's webinar qualify or for the 3 months mentorship program?
Okay.
Yeah.
So I'll answer that question. Let me quickly run through this, okay? I'm not going to ask questions anymore. So we just created a model, and what's a model? It's a formula or a method that we use to create by following the pattern in the data, okay? And then what are the important factors? Now, these are very critical things in machine learning because it's the important factors that will help you make your predictions. Among all the information you had about the teacher, there was some specific information that were critical. So that was what formed that equation that we used. And so when we apply the model, your parents will they'll like to ask the principal if Mrs. J can tutor you at home. What important questions will you tell them to ask? Like, it's okay to talk and chat, but there's specific questions you need to get answers for. And these are the questions they need to ask. Is she nice? Is she fun to be with? And does she have above 5 points teacher grade or teacher rank? Okay? And so when they decided to ask, the principal said, Mrs. J is nice, she's fun to be with, and she has a 7-point teacher ranking. So will she then be a good teacher for you? The answer is yes, because, I mean, even if she has 10 kids, regardless, that's not important. These are the important things, and this will make that decision for your parents. So in summary, we've learned one of the fundamentals of machine learning, which is the patterns. What's the best way to manage missing data? Go get the data. What other methods can we use to manage missing data? We talked about mean, we talked about median, we talked about imputation, we talked about guessing, right? What types of variables do we have? We talked about independent and dependent variables, and then describe the variables. An independent variable is what will help you make a decision about your target, which is the dependent variable. What is another name for one of the variables? Your independent variable can be called a regressor or a predictor. Your independent variable is what you call your predictor, okay? Independent, meaning it stands by itself. But because it stands by itself, it's what will determine the final result you're looking for, okay? So that's your predictor. Now, the dependent variable is what will tell you the target. The target is what you're looking for. Is she a good tutor or not? Okay, am I going to make money or not? What's going to be my sales? Those are your targets. Why do we need to know the important variables? Because you always have many things coming, and that's what you call noise, right? You always have many things coming, but they're just a few variables that are necessary to make that decision for you. And so that's why you should always go for your important variables. All right. So I quickly ran through that. I wanted us to go through this together. And so congratulations. You have just solved the problem using the basics of machine learning. You should be very proud of yourself. And I was going to talk through data science because I know many people talked about data science, how to become a data science. As a data scientist, if you look at what's in the center there, I know some of you would have seen this, and it's true. So I'm picking it up from a popular source. You can also go there and read it. For you to be a successful data scientist, you have to know how to code, you need to know statistics, and you need to have some basic business knowledge. And if you look at the way schools are structured, they're either arts or science. Social sciences are usually not coders, right? But you have to be in the middle, and you need to know how to develop software to some extent to be very successful. I won't run through this. And then I gave an assignment. I'm not going to run through the assignments either, but for you to qualify for the scholarship, this is what I'm looking for. I'm looking at how you're going to answer these, do your assignments, right? Number one, you're going to create a data set yourself based on, for students in your school, you target based on this kinds of ways, data tagging, like labels that you can have. And then number two, you look around and write at least one paragraph on how data can improve the things we do. The things we do, just like smart city, don't worry, I'm not looking for something very ambitious. Just look around and look for a simple problem to solve around you using data. And then you give me the model that you're going to come up with and the important factors to consider, and then how you're going to apply it, which is what you have for participant ID 10. When you come up with that model, what are you going to apply, or how are you going to apply it to give me the answers for number 10? And when you look at it very well, you see GPA is missing, and whether this person is going to be admitted or not is what your target is. All right, so get this done. I'm going to send out an email on the assignment, how you're going to submit it. Respond based on that. Then that's it. That's how I'm going to select those that will move on with the scholarship. Okay. Any questions to wrap up? I'm still going to take questions.
Okay, awesome. If you'd like to ask a final question, okay, you'd be okay. Please ask your question.
Please, can you repeat the assignments?
The assignment will be communicated to you, okay, by email. We'll give the details of how you do the assignment and also how you would submit it. Okay, so expect an email from us as soon as possible, communicating all those, and you'll get the details needed. Okay, Lawal, we'll take your question, please.
Please can
1 plus 5. Could you please ask your question?
Jesus, 1 plus 5.
my question is it possible for all cities to be a smart city?
Is it possible for all cities to be a smart city?
Yes, sir.
Yeah, it's very possible. There's no limitation. Anybody can be, or any city can be a smart city. There is no restriction on we can only have 10 or 20. Okay, so if you're thinking of building or helping your community to be smart, please go ahead, jump right in.
Okay, awesome, Moyo. Can we please take a few questions from our YouTube audience? I'll just run through a few. One is this: which website can I use to learn data and coding and hacking?
Awesome. So there are some free resources there. There is edX, EDX. Just type in EDX. Type in machine learning, data science, data engineering, anything data, type it in there. There are ways to register for those classes free. It's not just going to give you a certificate. That's it. But you're going to acquire that knowledge. There is Coursera as well. It's also free. So those resources, I'll also include them in what will be sent out to everybody. Okay.
Okay, awesome. Another question is Python the only programming language used in data science?
No, Python is not. Python is not the only language. There's also R, and there's also ML machine. This one's from Spark machine learning library, and all of these don't work in isolation as well. There's some other packages like or maybe environments basically that will help your models run better. But if you just want a very small model that functions, even Excel can work, right? So R, Python, Excel, they're good tools.
Okay, awesome, thank you. Another question is, how do you encrypt data? And a follow-up question is, what is an encryption key?
So when you encrypt data, encrypting data means that data, the way I've shown you in a data set just now, is not visible to anybody without the encryption key. Now, the encryption key works in a way that when I send you data, imagine someone sending you a package, just imagine a gift, you're receiving a gift. Now, whoever opens the gift without the gift key, which is the encryption key, whoever opens that gift without the encryption key will not understand what's there. It's either they cannot open it, or if they eventually open it, they just don't understand it. And the encryption key is what both of you would have exchanged some keys to say, well, when I give you this key, use this other key to open it. So whoever is going to open that parcel or package or that data must have that other key that will be used to open it, that has been known as the key ahead of time. So encryption key is a way to lock up your data for only the recipient that has the key to open it.
Okay. Okay, awesome. So for other people raising their hands, please just drop your questions in the chat box. As I said earlier, we'll attend to them on the TechQuest website, so you can proceed to, so say by Monday or later next week, you can proceed to the website to get the answers to your question, all right? With this, we have come to the end of this introduction to data science webinar. A special thanks to Moyosore Lawal for giving her time. It's 6 a.m. where she is, or it's about 7 a.m. Thank you so much for the willingness to engage the community members and the audience to give us an introduction to this. Thank you so much for your time.
Thank you too.
Yeah. Have a great rest of your day, everyone. I wish you the very best. Also, thanks to the TechQuest team in the background doing the work. All right. Bye, everyone. Have a lovely rest of.
Bye.
Bye.